Hi everyone, how are you doing? Can you please let me know if audio, video, and everything is clear? Just let me know, okay? Once you confirm that everything is good, then we can start. Okay, so let's just confirm. How are you doing all? Okay, so happy group Unma. Okay, everything is fine. Cool. So in this session, we are going to study calculus in the sense that we will be covering everything from very much scratch, and then we will be aiming that we should be finishing most of the topics in this particular session. If there is some topic that we are not able to finish in this particular session, then we will be taking that topic in the next session. Okay. ठीक है. So let's get started. Now we are going to start with the very first topic, which is limits, right? So let's get started with the limits. Okay, yeah, hi everyone, happy Guru Purnima. So I hope you can see my slide also, right? So let's get started with the limit. Now, so as I told you, the objective of this session, okay, so let me just tell you the objectives is to basically, the main objective is to revise, the main objective is to revise in as much as less time as possible, and then we will be solving the questions. So revision and PYQs and some standard university questions. Okay, so this is the objective of this session. Now we will be doing this revision little quickly, in the sense that I will be assuming that you have already watched some of our lectures. Even though you have not watched, you should be able to understand all of these things. Okay, cool. Now let's start with the topic limits. Suppose that this graph is given to you. Now I hope you can see this graph. Okay, so suppose this graph is given to you. Now in this graph, you see there is one dot, right? I mean this dot, this hole or this particular circle that you can see. Let's just assume that this is just a normal graph. This dot actually doesn't matter to us, but just for the sake of visualization, I have this dot. If you don't want to assume, then you can have this this continuous graph. Okay, so suppose that this is the graph that we have, and now I want to check whether the limit exists at particular point A or not. Okay, so I hope my question is clear to everyone, that what I'm saying is that I want to check whether the limit, okay, I know that I have not defined the limit, so I will be defining what is the limit. So the question is that whether limit exists on a point A or not. Okay, this is the question. Now, as you can see this graph, so like this graph seems to be very nice graph, in the sense that this is a contiguous graph, right? Now let's just first define that what is this limit. Limit is basically, so at any point if I say that that I want to check the limit or not, so limit is basically something which is saying that you are at this point. Now if you come, now listen, if you come from the left, okay, if you come from the left at this point, or you come from the right at this point, so basically either you come from the left or you come from the right. This is what limit says, that you come from the left or you come from the right, then the function value doesn't change. So which means that if you are coming from the left, means that if you are talking about a point which is immediately previous to this A and immediately next to this A, okay, immediately previous and immediately next, so basically you are saying that let me talk about a point, this is A, let me talk about a point which is left of A and which is right of A. Let's suppose there is a point on left of A, there is a point on right of A. If I talk about these, at these 2 points, whether the limit exists or not, it will depend on whether these 2 points are having the same value or not. Which means if you come from the left, then what is the value that this function is taking? I think this is the value, right? Okay, so this is the value that if you come from the left, then this is the value that this function is taking. If you come from the right, then this is the value that function is taking. What do I mean by coming from the left or coming from the right? Just see this x-axis, okay, just see this x-axis, and now I'm talking about this point which is just immediately left and immediately right. Okay, so if at these 2 points, as you can see here, if at these 2 points the values are almost same, Okay, I mean values are same, which means at immediately left you have this value, immediately right you have this value. Is this any difference between these two values? See, just don't don't look at this whole, I mean, which in the sense that these 2 points are extremely near. Just assume that there is no distance between these two lines. Okay, so these two, this is no distance. I mean, just for the sake of visualization, I am having this distance. Otherwise, there is no distance. Okay, suppose that these 2 points are extremely near. If these 2 points are extremely near, then in that case, does there is any difference between these two values? Currently there is no difference, so I will say limit exists. So I will say limit exists. Why I am saying limit exists? Because I am able to say that f of a minus h is same as f of a plus h. What do I mean by that? That function value immediately left of this a, immediately left means this point, okay, immediately left means this point, which is a minus h, and immediately right means this point, which is a plus h. So immediately left and immediately right, if you check the values, then these values are same. That is why I will say limit exists. Okay. Now some of you might be asking, what is this h? H is just very close to 0. I mean, h is some number which is very close to 0. Okay, so which means if you if you talk about this a, immediately left means you are very close to a, still you are left. Okay, which is a minus h. Immediately right means this point, which is a plus h. Okay, I hope these 2 points are clear. Now let's see a graph where the limit won't exist. So suppose I have this graph. Okay, let's suppose this is the same graph I have, and now let me try to show you that in what case limit might not exist. Okay, so for example, let's suppose I go here. Now let me try to show you that at what for what point limit, I mean for what kind of graph limit might not exist. So see, suppose your graph is looking something like this. Okay, suppose this is the graph. Now you might say, what kind of graph this is? This is this discontinuous graph. That is okay, I mean that is fine to you. Now basically there is a, okay, so suppose this is the graph that you have. At a, let's suppose that at a, this is the value that function is taking, whatever it is. Let's suppose this is the 5. Okay, the function is taking the value 5. Yes, Varun is asking, can I watch the lecture if I am not having any clarity? Yes, you can watch the lecture. Okay, so suppose that fa is 5. Is this clear to everyone that fa is 5? And now let's see that what is f of a minus h. What is f of a minus h? Just less than this a. It is also 5, right? It is also 5. Just immediately left to a. Immediately left to a is also 5. Now tell me what is fa plus h, which means immediately right to a. If you go immediately right, then this is the point that you're talking about, right? So at immediately right, let's suppose this is the value which is 8, or maybe let's suppose 10. So fa is 5, fa minus h is also 5, but as you can see in this particular graph is that fa plus h is 10. So fa plus h is 10. Now let's just see that how we are going to understand this limit. So basically at this particular point the value is 5. Immediately left the value is 5, and immediately right the value is 10. So if immediately left the value is something and immediately right the value is not matching, then we say the limit does not exist. So here we will say limit does not exist, right? So let me just write it here. So in this graph at x equal to a, limit does not exist, right? Okay, I hope this is clear to everyone. Limit right? Okay, now let me move further. So now you understand that what is the graphical representation of limit exist and not. So now you can also tell me the mathematical definition. What is the mathematical definition? If immediately left, if you are coming from immediately left or immediately right, the values are same, which means these two values are same. And what is h here? H is something which is basically tending to 0. If that is the case, then we will say that at x equal to a limit exists. Okay, at x equal to a limit exists. If that is the case, I hope that is fine to everyone. Let me know if there is any issue you are facing. Okay, okay. If that is fine, then we can move further, right? Cool. So now let's just see this question. Okay, this question is saying find the following values of this particular graph. So basically they have given one graph and then they are asking you to find the following values. So let's just quickly find out these values, right? Okay. Tell me from this graph, okay, by seeing this graph, tell me what are these values. What is -1 plus? I mean, if you are -1 plus means if you're coming from the right, okay, at this -1, maybe I can just zoom this out a little bit more, then you can understand this. So basically, just a second, let me just zoom it out and then you will be able to understand this. So basically this graph is given to you and then they're asking some values. Now tell me if you're coming to -1 from the right side, -1 plus, which means this is -1 plus, right? This particular point, -1 plus. If you're coming to this graph from the right side, then what will happen? -1 plus value is, I think, this is +1, right? This is +1. So here you will be saying this particular value is +1. So the value which is given here is +1. Okay, so let me write here, this is +1. I hope that is fine to everyone. This is the part A. Let's just see the part B, which is saying 0 minus. 0 minus means they are talking about, I think this is 0. 0 minus means they are talking about this value, right? So just immediately left to 0. What is the answer? Immediately left to 0. What is the answer? At this point, immediately left to 0. Just let me know. So it is 0, right? Great. Similarly, 0 plus, immediately right to 0. What is the answer? At 0, actually the function value is not defined. Okay. Immediately right to 0 is 1. Immediately right to 0 is 1. At 0, what is the answer? At 0, what is the answer? At 0, it does not exist. Why? Because the function is not defined. Function is not even defined at 0. So that is why at 0 it does not exist. At 1 minus means immediately left to 1. It is 2. It is 2. Okay. So, sorry, just a second. This F0 does not exist. But if you ask me, this is very interesting. Let's just see this E and D, difference between D and E. Okay. Let's just see the difference between D and E. So there are two questions. One is D, which is saying this one. Another one is E. So let's just see that what is the difference between these two. They are saying, first is saying limit x tends to 0 fx. So what is this limit x tends to 0 fx? This particular value and this f0, both are actually different. Can anyone tell me what is the answer of D and what is the answer of E? See, limit x tends to 0 fx, which means you are talking about this limit, right? The limit of fx. So limit x tends to 0 fx is defined like this. I mean, if I say limit, let's suppose if I just ask you that limit, like basically I want to ask you the limit of f, I mean s tends to 0. This is the limit at a, okay? This is the limit at a. So you can say this is same as limit of s tends to 0 f of a minus h, which is same as I mean this is the limit at f x equal to a. Okay, so which means if someone asks you this particular thing, then what is the answer? So let me see what you are getting. See, just see the difference between D and E. So basically, this D is saying that D means you're talking about limit at at fx. I mean at x equal to 0. So which is saying that this is the value you're talking about. Okay. So now tell me, are these two things are good? Which means are at x equal to 0, the left limit. Okay. At x equal to 0, the left limit, which means let me write it maybe on the next page. So the left limit here is something like this, which means this limit h tends to 0, f of x minus h is basically the left limit at x equal to 0 is what? 0. And what is the right limit? This is called right limit, right? At x equal to h. What is the right limit? This is 1. This is 1. So since this limit does not exist at 0, since limit does not exist, that is why you will say this does not exist. Is this okay to everyone? So why are you saying this D does not exist? Because the limit does not exist. Because left and right limits are different. Okay. So you will say it does not exist. What about E? What about E? E is asking about F0. So at F0, since the function is not defined, so you can also say it does not exist, right? Or the function is not defined, whatever you want to say. Okay. So here you can say function not defined. Okay. Now let's just see other examples, maybe. I mean other questions. So here, let's just see this 1. So basically at 1 also things are very interesting. So what is this 1 plus? Let's just see the answers at 1. Let's just answer all of this. What is 1 minus? 1 minus means just before 1. Just before 1, this is 2. Just after 1, what is this? This is also 2. And if this is okay, this is basically, I mean, see, there are 3 things, right? These are the 3 things. Now, let me just define. So these are the 3 things. Now you can answer F and G separately, but this H is little interesting. H is basically, you can answer this only when this is equal to, this is defined first of all only when this is basically limit x tends to 1 minus fx equal to limit x tends to 1 plus fx, which means you can answer this H only when 1 minus and 1 plus both are equal. Okay. So basically here at this point, since both are equal, you will say this is 2. Now at F1 the value is 1. So here you will say this is 1. Okay. See, this F you can answer independently, G you can answer independently. This H is actually the basic limit that you have. H is the real limit. Okay. This is limit of function at x equal to 1. This is limit of the function at x equal to 1. And that is equal to left limit. This is left limit. This is right limit. Okay. So basically this function value, the limit value should be equal to left limit and right limit. And what is the answer of this? What is the answer of this? This F1 is independent of the limit. This is very interesting. So basically the the limit values, limit is saying if you're coming from the left or you're coming from the right. It does not talk about the particular point in such, okay? It does not talk about the particular point. At x equal to 1, what is your behavior? It does not talk about it. Okay, at x equal to 1, what is your behavior? It does not talk about that. Does this make sense? Okay, so basically this is one. Now, I hope everyone is clear about the limit definition. Okay, so let's just see the answers. Now the answers are the same that we talked about. So basically these are the answers that we have. Okay, so yeah, so all the answers are good. And here there is one more question, the 3 minus. At 3 minus this is just 1. So I think all the answers are good, right? Okay, I hope you understood that how limits are defined. Okay, now can I move to the next question? Does this is this okay to everyone? Let me know. If there is any doubt, then also let me know. Okay. Cool. So I think this is okay to everyone, right? Okay. So now let's just move to the next question. So basically, let me quickly revise you that what we have already seen in the lectures that are uploaded on the YouTube. So basically, on the YouTube lectures, we already have all of this there. Let me just tell you. Okay. So see here I have said like this is the left hand limit, this is the right hand limit, right? So which means that I'm saying that left hand limit means a minus s, right hand limit means a plus s. That's all. Okay. So Manish is asking if dot were not there, then it will be undefined. No, limit won't be undefined. Yeah, that's very interesting question. So let's suppose that this dot is not there. Let's suppose the function is not defined at x equal to x equal to 1. Then will the limit be defined? Yes, limit will still be defined. Okay. Yeah, but this f1 will not be defined in that case. This f1 will not be defined in that case. Otherwise, limit will be defined, which means all of this are same. Even for this graph, all of this is 2 to 2, but this is not equal to 1 because the function is not defined at x equal to 1. Okay. Cool. So now let's move to this. So basically, there are few forms of the limit. There are few forms of the limit which are basically something like that. I mean, infinity upon infinity that you might have seen. 0 upon 0, infinity minus infinity, 0, 0 power 0, 0 into infinity, infinity power 0, 1 power infinity. There are few forms of limits. Now, can anyone tell me if it is, let's suppose if it is 1 power infinity, right? If it is 1 power infinity, then why it is not 1? I mean, why we are saying this is some indeterminate form? Why we are not saying this 1 power infinity is just 1? Can anyone tell me? See, this one is not exact one. Okay, there will be some function. There will be some function which will tending to 1. I mean, there will be some function which will be tending to 1, and I will be having that power. Okay, that power infinity where fx is tending to 1. Okay, yeah, it is not 1. It is tending to 1. That's the difference. Otherwise, if it is real one, then the story could be different. Okay, so it is basically not real one. I mean, this is some function which is tending to 1. Okay. Now we will be basically we will be seeing few methods which are let's suppose factorization, rationalization. I mean, these things. These are few methods which will be handy to you. In the sense that these methods are not any I cannot say like the brahmastra or something. Okay, I mean you have to apply your sense to solve the limit questions, but there are different patterns, and all the patterns can be solved using these methods. So whatever pattern you see, that pattern can be solved using these methods. Either you can apply factorization, rationalization, or some standard limit, some substitution, infinity upon infinity. I mean, whatever kind of form there are, we can solve those forms using these methods. So let's quickly see. Suppose that you want to solve this. So the first method that we want to see is basically factorization. Okay, suppose you want to solve this particular question. So what you can do, you can basically factorize this. So basically, suppose you want to solve this x cube minus 1 upon x minus 1. If you want to solve this limit, you can just factorize this x cube minus 1, and then this x minus 1 and x cube, like some of the factor might get cancelled, and then you can have your answer, right? And then finally you can have your answer as 3. Is this okay to everyone? Okay, Ria, we will be coming to that. So this is one method. I mean, you can just factorize. For example, this is the question that is given to you, and if you want to solve this question, this is the question number 2. If you want to solve this question, maybe you can factorize this square root of cube minus 1, and then you can solve this question. So basically, like I'm just quickly going through all the patterns. So suppose you want to solve this, maybe you can factorize this, and then you can solve this question. So that's already there on the YouTube. See, on the YouTube. Okay, that's already there in the same playlist. I have put these slides, the slides that you are currently seeing, that is already there on the YouTube. Okay, cool. Now so what I'm saying here is that there is one method, factorization, which we have just covered in the sense that we have seen 3 examples, and you can just factorize them, and then you can solve it. So factorization is done. Now let's see the next method, which is rationalization. I'm just quickly going through these slides because that's already there on the YouTube. So for example, let's suppose I want to solve this question, and I want to use, let's suppose, the same method, which is the factorization. So you can just factor this out, and then you can solve this. Okay, I mean the solution is on the next page, so that's why I'm not solving it. I mean this x square minus 9 can be written like this, x square plus 2x minus 3 can be written like this, so that's why you can solve it. Okay, so this is the question that you can take as an homework for the factorization. Okay, using the factorization, you can solve this question. Similarly, using the factorization, if you want, you can solve this question using the factorization again. So it is given on the next page. The solution is on the next page. You can solve this using the factorization. Okay, take it as an homework. Similarly, take it as an homework. Solution is on the next page. Okay, solution is on the next page. So you just take it as a homework. This is the solution. Now let's see the next method, which is called rationalization. Okay, let's see the next method, which is called rationalization. Now this rationalization is basically one method which says that you can do one thing. You can multiply by the rational form of this. So if it is minus, then you can multiply the plus in the numerator and denominator, and that's how you can solve this particular question. Okay, so basically you can multiply by this, and then finally you are getting this particular form, and now you can put the limit x tends to 0, then you can get 1 as an answer. So rationalization is very easy. Whenever you see some square root or something, where you can just multiply by the rational form, then just do it. Okay, so basically as I'm saying, these are just tools. Okay, factorization, you just factor it out. Rationalization, whenever you see there is a chance of multiplying and dividing, you can do it. Now let's just see use of standard limits and other forms. Okay, other tools to solve the questions. So before that, there are few identities. I can tell you that if you are having if you are having plus minus, then you can definitely take limit inside. In all the cases you can take limit inside. If you are having multiplication, then also you can take limit inside. If you are having divide, then also you can take limit to the numerator and denominator, which means, let's suppose you are having something like this. Okay, let's suppose you are having limit fx upon gx x tends to 0, then you can definitely write it limit fx x tends to 0 upon limit x tends to 0 gx. Okay, you can definitely write it something like this, and I'm assuming here this limit is not 0. Okay, this limit is not 0, otherwise that will be a problem. If you want, you can solve it definitely, but like for example, just tell me, is this correct way to say that? Or maybe let me write, let me take some example, something like this. Tell me, is this the correct way? Is this the correct way? Can I write something like this? Or maybe let me take a square here. Can I write something like this? The answer is no. Why? Because this denominator is actually 0. If the limit is 0, if this limit is 0, then obviously it doesn't make any sense. I mean, if without 0, you can, I mean, if you are not separating it out and then you can solve it, then why not, right? If this limit is 0, then it doesn't make any sense. So that is why this is wrong. Obviously this is wrong, right? So that's why I'm saying that here the lower limit, okay, the lower limit should not be 0. This particular limit should not be 0. Okay, this m should not be 0. I mean, these are few identities you can consider. So basically you can take this limit anytime, anywhere. Okay, I mean, if that's the case, you can take it in the power. Okay, I mean, in the power, you can separate it out anytime, anywhere. Okay, so there are one or two limitations that if you are doing in the power, then this L must be greater than 0, but you don't need to remember it. I mean, for the gate purpose, this is not required. Actually, that is the limitation that we have, because this function, like we will be taking the log, and then we need to prove it in proving this. Okay, from here to here, we need to take log and all, and that's why we need to have this L greater than 0 or something. But you don't need to remember. You can just remember that you can take this limit inside anywhere, given the chance. Okay. So Twinkle is saying here we can cancel the common terms. Yeah, you cannot cancel. I mean, this is the separate function. So basically you are solving it differently. So that's the problem. You can cancel here. Okay, you can cancel it here, and then you can say answer is 0. That's fine. But you cannot separate out this limit. Okay, you cannot do this. Cool. And now let's just see few standard limits. Okay, standard limit in the sense that there are few frequently used limits that people are using. So sin x upon x is actually 1 if x tends to 0. E power x minus 1 upon x is 1. Yeah, that's also, this is the limit which is quite useful sometimes, that log of 1 plus x upon x equal to 1, limit x tends to 0. Okay. So let me go to the next page. So what I'm saying here is that limit x tends to 0, log of 1 plus x upon x, this is 1. Okay. Now suppose I give you one example, and now you need to tell me whether this is true or false. Okay. Now you just need to tell me whether this is true or false. Limit x tends to 2, log of x minus 1 upon x minus 2. This is 1. Just tell me, based on the above identity, based on that, tell me whether this is true or false. See, what you can understand from here is that if you are having any identity, okay, if you are having any identity such that log of 1 plus x upon x equal to 1, and where x tends to 0, then what does this mean? It means you can have pretty much any function. Okay, you can have pretty much any function where log of 1 plus that function upon the same function, and where the function is going to 0. I mean, it could be anything. If that is going to 0, I mean, if this term is going to 0, and the exact same term you have in the denominator, and this is also going to 0, then this is 1. That's all. Okay, then this is 1. Okay, I hope you understood. Now if you want to answer this particular question, then you can say that C. If you want to answer this, then you can say C. Here you can rewrite it like this: limit x tends to 2, okay, log of let's suppose 1 plus x minus 2. Can you write like this? Yeah, I think we can write like this, right? Upon x minus 2. If you can write like this, here this is going to 0, this is also going to 0, right? And What are the checklist? What are the two things that you need to check? Both should be same. Okay, it's not like that they can be different. That's very important. Okay, they cannot be different, both should be same. This is the one checklist. Second checklist is that both, or I mean, are going to zero, basically are tending to zero. If that is the case, then this answer is 1. Okay, so that's why this is 1. I hope you understood. Now let me ask you next question. Suppose you have something like this. Suppose 2x minus 4. You have something like this. Now tell me what is the answer? See, is this going to 0? Yes. Is this going to 0? Yes. So since 1 plus something going to 0 upon something going to 0, should it be 1? Should it be 1? Tell me. I don't think, right? I don't think. It cannot be 1. Why? Because both functions are not same. So you need to have both functions as same. So what can you do to make both functions same? See, both functions are not same. That's why directly you cannot write 1, right? Directly you cannot write 1. But you can do one thing, and then you can solve this question. You can say that, see, I am taking common. And what term you can take common? You can take 2 common, and then you can say this is x minus 2. And then this is 1 by 2 is outside. 1 by 2 is outside, right? This 1 by 2 you can take outside, and then you can say that this is x minus 2, right? Now this is same. So this quantity is 1. This quantity is 1. So final answer is 1 by 2. Final answer is 1 by 2. Okay, so now everyone understood, right? So basically, don't do this mistake that this is going to 0, this is going to 0, then this is 1. No, both has to be same. Okay, that's also one thing that you must understand. So now this identity, I hope everyone is clear about it, right? This is quite useful sometimes, and this is also, I mean, you can remember this. Otherwise, don't worry about this identity. We can even drive this identity. Okay, so we will see how to drive this identity. Cool. But you just remember these two at least. Are these two fine? Okay. Or if you want, you can remember this also. Okay. So, I mean, just remember these standard limits. It is good that you remember. Otherwise, we can definitely use something called as L'Hopital rule, and then we can definitely drive these identities. It's not a big deal. Okay. But it's better if you remember. Cool. Now, I hope these things are clear to everyone. Now, okay. Now, let's just solve this particular question. So here I have two questions. One is this one, another one is this one. Since I have already solved these questions, that's why I mean in the YouTube lectures only. So that's why I just have the direct slides. Okay. Sorry. Just a second. Now let's talk about this. So if you want to solve this question, I mean, one of the way you can take, see, there is no fixed formula, there is no fixed method. We are just using our intuition. We are just using our practice that we have already seen. So what you can do from here, you can take 5 power x common, and then you can write it something like this. Then you can say this is e power x or a power x minus 1 upon x. I mean, something like this, right? So if you see, if you try to match this with the standard limit that we have already seen, okay, try to match this with the standard limit, which is a power x minus 1 upon x, then it is log e. Okay, so basically this is given to you, right? Now let me do one thing. Actually, I have many questions to solve. That's why I have few questions already on the slide. I mean, the solution is already on the slide. But still, let's suppose you take 5 power x common. This is 3 power x minus 1 minus 3 power x minus 1, right? Upon sine x square. Now what you do? You take 3 power x minus 1 again common. Then this is 5 power x minus 1 upon sine x. I mean, you don't need to write like this. You can directly write upon sin x square. Okay. Now what you can do, you can multiply and divide x in this, right? Multiply, divide x in this. You can multiply, divide x in this, and then there will be x square, right? I mean, x square multiplied by this quantity. Now this will be log 3. This will be log 5, right? And then here you have x square upon sin x also, sin x square. Okay. Is this okay to everyone? Yeah, earlier I used that white screen, so that was my mistake. I think I should have used the black screen from the starting. So basically, this is the thing you are getting, right? Now we have seen one identity which is basically sin x upon x equal to 1, and also actually x upon sin x tends to 0 is also 1. Okay, so now you can say that here this is 1, this is 1 square. So finally you have log base e. Okay, basically this this particular identity is base ea. Okay, base e. So now you have log base e 3 multiplied by log base e5 as your answer. So this is the final answer. Okay, cool. So similarly you can solve this. How you are going to solve this? Let me just show you. So if you want to solve this, you can basically say that this e power x minus q upon 2x, this is given to you. So e power x minus q upon x, you can I mean, if you want to have the finite answer, then this should be the standard limit. So which means q should be 1. Okay, q is 1 here, and then p should be okay, if this is 1, and then since the limit is 1, so p is coming out to be 2. So that's how you can solve this particular question. Okay, cool. Now let's move to the next form of the questions, which is solving infinity upon infinity. Let me know if everything is clear till this point. Okay. Now let's just let's just see how to solve this infinity upon infinity, right? Cool. So if you want to solve infinity upon infinity, then generally this form arrives because of the polynomial. Okay, you take the highest power common, whatever the highest power. So which means here this is the n into n plus 1 only by 2. This is n square, this is n square. So basically it will be 1. So let's suppose that you are having, let's suppose maybe I have the example here. Okay, let's suppose that you are having something like this, x cube, okay, x cube plus x upon x power 5 plus, let's suppose, x power 4. And now let's suppose you want to solve this particular identity, limit x tends to, let's suppose, infinity. Now isn't it infinity upon infinity form? Tell me, isn't it infinity upon infinity form? Okay, so since this is infinity upon infinity form, then how you can solve this particular question? You can take the take x power 5 common here. Okay, so basically it will be x cube, you can take common from this. It will be 1 upon x square, 1 plus 1 upon x square. You take x power 5 common, it will be 1 plus 1 upon x, right? Okay. Now you can see that here this x power 5 and this is x cube, so it will be just x square. Now if you put this x tends to infinity, then what you are getting? This is 1 plus 0 upon infinity into 1 plus 0, something like this. I mean, it will be 1 upon infinity, which will be 0, right? I mean, this is a finite number, 1 upon infinity, this will be 0. So anyway, basically what is happening here, that you take the highest power common. So basically this is, let's suppose whatever it is, right? You take the highest power common, and then you just try to solve your question. So basically it is, let's suppose, n square upon n square, you take the highest power common. Here like n is getting cancelled, and then it is 2n upon n plus 1, and then from this also you take this n common. Okay, so what I'm saying, let's suppose it is 2n upon n plus 1 limit n tends to infinity. You take this n common, this will be 2n upon 1 plus 1 by n. Okay, and then n and n will get cancelled out. It will be 2 upon 1 plus 0, which is just 2. So 2 is your answer. We will see more examples, don't worry. Okay, so the infinity upon infinity form generally arises because of the polynomial. Cool. Okay, now there is next form which is infinity minus infinity, right? So there is a next form which is infinity minus infinity. Now this infinity minus infinity comes, it can come because of any reason, but the way or the trick is to solve is basically, how you are going to solve this is basically you are going to see that this particular form, this particular term which is forming the infinity, and this particular term which is also forming the infinity, both of this can be clubbed in some way. If that is the case, then you can solve this particular question. Okay, can you club both of this in some way? Just let me know. So basically, for example, here let me just go to the next page. Okay, see, if you put x tends to infinity, this will be infinity, right? Because the polynomial here is basically having the higher power, right? This is x square. So if you try to solve this, x square plus x plus 1 upon x plus 1 minus ax plus b. Okay, here limit x tends to infinity. If you try to solve this, then what will happen? What's going to happen? You are going to say that this particular term is infinity, right? This particular term is infinity. This particular term is also infinity. So it is infinity minus infinity. Now what you can do, you can try to club both of this. How you can club? You can say this is x square plus x plus 1 minus x plus 1 into ax plus b upon x plus 1, right? So the idea here is that if you are having infinity minus infinity form, in that case what you are going to do, you are going to basically take take both of these terms and try to basically try to club both of these terms. That's the way. Okay, you try to club both of these terms. Cool. So basically you just club both of these terms, and then once you club, then let's just see how to solve it. So here if you just multiply, I think the term that is going to be 1 minus a. Let me just go to the next page. So if you just multiply these two, then the x square coefficient is basically getting 1 minus a. The x coefficient is 1 minus a minus b, and this is 1 minus b. Okay, and then finally you're getting upon, okay, this is x minus 1 or plus 1. This is x plus 1. Cool. So basically this is the term that you are getting. Now if you want to really solve it, then obviously this x square coefficient should be 0. I mean, you cannot have x square in the numerator. Otherwise there is no point. I mean, you cannot solve it. I mean, if this is finally leading to the finite term, then this x square coefficient must be 0, isn't it? So since the x square coefficient must be 0, that's why you can say that here you can basically write it like this, that 1 minus a should be 0, and then if this is 0, then you can solve for this, right? And then finally what will remain is basically something like this. Now if you want to solve it, just divide by x. Okay, just divide by x. If you divide by x in the both side, it will be you take x common, it will be 1 plus 1 upon x. You take x common from here also, it will be 1 plus this x, right? X will get cancelled out. Now you put x tends to infinity. If you put x tends to infinity, then you can say this is 1 minus a minus b, and then this is 1, right? And here a is 1. That's how we have solved it. And now based on the answer we can solve it. I mean, if it is 4, then you can put this as 4. Okay, so the final limit is 4. So this will be 1 minus a minus b equal to 4, and a is 1. Okay, so which means that b is coming out to minus 4. Let me just check it. Yeah, so a is 1 and b is coming out to be minus 4. You can just put a as 1, and now you can solve this. How to solve this? If you want to solve this, you can again take this x common, and then you can solve this. Okay, cool. So basically, if you want to solve this infinity minus infinity form, then what is the way? Anurag is saying that we can simply divide numerator and denominator by the largest power. Yeah, that is when you are having that is when you are having the infinity upon infinity form. Yes, that is true. Can you please last part? Please repeat the last part. Okay. See, is this okay to everyone that you are clubbing? Is this clubbing part okay? Okay. Till this point, I think everything is fine, right? Cool. Now, from here, what you can do, you can understand is that given that this limit finally is basically 4. I mean, it is given to you. It is given that this answer is 4, and then you need to find out the values of a and b. Okay. Since this has to be finite, for that you cannot have x square here. Reason being is that if you are having more power on the numerator, then this will always be infinite. Okay, this will always be infinite. If you are having more power, it is just like I ask you asymptotically. Okay, you are currently studying algorithms, I think, right? So basically, I mean data structure. So if I ask you asymptotically that n cube is greater or n is greater, I mean if you divide this, then since this is greater, this will always be infinity. I mean if you are having let's suppose something like this, and here something like this, what is the answer? Intuitively you can tell me, immediately you can tell me without even solving it. Answer is infinity, whatever you do. Reason being is that this is n cube, which will always grow faster than this n plus 1, right? So otherwise you can solve it. How you are going to solve it? You can take, highest power common here, highest power common here. If you take highest power common here, this will be the thing. If you take highest power common here, this will be the thing. Now you cancel out, right? Once you take the highest power common from the both side, you just cancel out. It will be n square. Now you put n tends to infinity. It will be just a finite number, but it will be infinity, right? Numerator will be infinity. So basically what I'm trying to say is that if you are having something like this, right? Then in this case, this numerator cannot have the higher power to make it finite. So that is why 1 minus a must be 0. Is this clear to everyone? Okay. So here, why 1 minus a is 0? Because numerator cannot have the higher power. So that's why I can say that to have this particular limit as a finite answer, 1 minus a must be 0. Okay. So 1 minus a must be 0. This is one thing, which means this is 0. Now, which means a is 1, which means this will be, if you put a is 1 minus bx, right? Minus bx plus 1 minus b upon x plus 1. And now you need to solve this particular limit. Limit x tends to infinity. That is given to be 4. That is okay. You need to find the b. Just tell me, isn't it again, okay, you can take minus 1 common or doesn't matter. So isn't it again infinity upon infinity form? Isn't it infinity upon infinity form? Since this is infinity upon infinity form, so what is the way to solve infinity upon infinity form? You take the highest power common in both the cases, in the numerator and in the denominator. So you take the highest power common, right? So you take this highest power common, which means you are going to take this x common, and then this will be minus b plus 1 upon x minus b upon x upon x 1 plus 1 upon x, right? Now you cancel this out. Now you put the infinity again. If you put the infinity again here, what will the numerator? It will be minus b. What is the denominator? It will be just 1. So finally you are having this particular limit as minus b, right? This particular limit is minus b, and that is given to be 4. That is why b is minus 4. That's how you can solve this particular question. Okay. So this is the way to solve this particular question. I hope you understood. So basically, how we are going to solve? If infinity minus infinity form is given to us, then in that case, we are going to convert this infinity minus infinity form into infinity upon infinity form. How? By clubbing this. Okay. You just club these two parts. The club part is very important. Just club these two, and then you are going to, once you club these two, then you are going to have infinity upon infinity. Okay, and you know how to solve infinity upon infinity. Take the highest power common in both the cases, in numerator and then denominator. Okay, now let's just see. Okay, so see, you take the highest power common and then you are going to solve this. Okay, so which is going to be minus 4. Cool. Now suppose this is the question given to you, some random question. What you will do? I mean, as you can just notice that you can rationalize, right? So you just rationalize and you are going to solve this. I mean, it depends on the question. Okay, so that's how we are going to solve these limit questions. Now let's see one rule which is called L'Hopital rule. Okay, that is applicable when you are having only when you are having the form 0 upon 0 or infinity upon infinity. Only when you are going to apply this particular rule, which is called L'Hopital rule. Okay, cool. Now let's just solve this question. Tell me, is it infinity upon infinity? If it is infinity upon infinity, then you can apply this rule. And how to apply this rule? You just say differentiate this and differentiate this. Okay. Although the differentiation we have not covered, but I hope the basic differentiation you know. This is 2n minus 5 upon e power n. Okay. If you differentiate this numerator, if you differentiate this denominator, this is going to be 2n minus 5 upon e power n. Now you differentiate again. Okay. Because it is again infinity upon infinity. Okay. Now you differentiate again. This is going to be 2 upon e power n. Right. Now tell me, can you differentiate this again? Can you differentiate this again? This is not infinity upon infinity. Okay. This is not infinity upon infinity. Since it is not infinity upon infinity, you cannot differentiate this again. Right. You just put n tends to infinity. And then what you will be getting? This is infinity. So that's why you are going to get 0 as answer. Okay. So you are going to get 0 as answer. Let me know if you have understood this. Okay. Cool. So let's just solve this. Just differentiate again and again, and then again you are going to get 0 as answer. Let's just solve this. Is it infinity upon infinity? Just tell me. Yes, since it is also infinity upon infinity, you just differentiate this. Sorry, this is not infinity upon infinity. This is 0 upon 0 because ln1 is 0 and this x tends to 1, right? This 1 minus 1 is also 0. So since it is 0 upon 0 or infinity upon infinity form, one of the form must be there. Since it is just one of the form, that's why it will be 1 upon x upon 2x, right? Which is basically 1 upon 2x square. Now you put x equal to 1, it will be 1 upon 2. Okay. I mean, I'm not writing this, but that is okay. I mean, you need to write limit x tends to 1. So basically, that's how you are going to solve this particular question. Okay. I hope that is fine to everyone. Okay. Let me know if there is any confusion. Let me know. Okay. Cool. So let's just move to the next slide. Can you solve this? Is this infinity upon infinity or 0 upon 0 form? I think yes, right? I think yes. Since this is also infinity upon infinity or 0.0 form, I mean this is infinity upon infinity form. So what you can do, you can just differentiate this. How to differentiate this ln square? You take this 2 into ln n, I mean log n. This is basically log n into 1 by n, right? And this differentiation is 1. Now this is log n upon n. Is this again infinity upon infinity? So you just differentiate this one more time, right? Now, since this is not infinity upon infinity, that's why answer is 0. So Vaibhav is asking, can we apply L'Hopital rule if it is infinity upon minus infinity? Yes, definitely. Okay, I mean this minus plus does not matter here. Why that is the case? Because this minus 1 you can take outside. I mean does not matter. Okay, I mean you can definitely take this minus 1 outside, and because it is just constant, so that's why it does not matter, right? Okay. Now let's see one more interesting form, which is 1 power infinity. Okay, so suppose there is some function which is given to you. Okay, suppose there is some function which is tending to 1, there is some function which is tending to infinity. Maybe something like this. Maybe you can say that there is fx, there is a gx. Okay, here let me go to the next page. Here this fx, this is gx. Here this fx is tending to 1 and gx is tending to infinity. Okay, this is one of the last I can say indeterminate form. Maybe let me just recall you. See, so we will be having the limit problems in all of these forms. Let me just show you. See, this is infinity upon infinity we have seen. Can you tell me how to solve infinity upon infinity? Tell me quickly. How to solve infinity upon infinity or 0 upon 0? This is using the L'Hopital rule, right? Or this generally this infinity upon infinity, if you are having using the polynomial, then you can take the highest power common. Infinity minus infinity, you just club them out. Okay, I mean if that is infinity minus infinity, you can definitely club them out. So, and now we are going to see these powers. These powers are generally solved using the log. Okay, solved using the log. And this 0 into infinity or something. So basically we can definitely most probably able to convert this 0 into infinity into something like that. I can say maybe, I mean there might be some way. Maybe you can take log, or maybe something will cancel out. Okay, but let's just see how to solve this 1 power infinity. Okay, 1 power infinity form. So here currently I am going to show you that how to solve this 1 power infinity form. See, see, this fx, let's suppose this fx is some function which is tending to 1 for some x tends to a, which means that if x tends to a, then fx is tending to 1 and gx is tending to infinity. Okay, so finally you can say this is tending to a, this is tending to 1, this is tending to infinity. So the final form is basically this is a form of 1 power infinity. I mean there could be any function. Suppose if I want to say that this is the form of 1 power infinity. Okay, let's suppose limit x tends to a. Suppose I want to say this is the form of 1 power infinity. Then what will I say? Here this fx, can you tell me that limit x tends to a, where will fx tends to if I want this form to be 1 power infinity, and where will gx tends to? Gx should tend to infinity, but if I want this form to be 1 power infinity, then you can say fx is tending to 0. Which means if fx is tending to 0, then this form is 1 power infinity, and gx is tending to infinity. Then this is again 1 power infinity, right? So you take any one of this, okay, and then you can solve that. So let me take any one of this. So is this fine if I take let's suppose this one, I mean this particular form, and let me just show you, right? So let me just take this form and let me just show you. So which means let's just solve 1 plus fx power gx. Okay, and here, I mean here this, as you know, right? Okay. I mean, see, depending on the question, you can definitely solve, but we can basically just simplify this for all the questions, which means like again and again we might not need to solve. Okay. Can I simplify this for all the questions? Maybe it is better. Isn't it better if I simplify this for all the questions? Right? Let me know. Okay. Okay. So what you can do, you can basically take okay, you can take log both side. Let's suppose let's suppose that here this particular limit is L, and you want to find L, right? You want to find L is a finite number. I mean, I'm assuming that L is a finite number, which means this limit exists. It doesn't matter basically, but that is fine. So you take log both side. Okay, you take log both side and log of this particular thing, right? This whole thing. You take log both side? I think you can definitely take, right? Whatever this is. Okay. Now tell me, can you put this limit outside of this log? I think we can put it. As I told you that you don't need to worry about this much in moving the limits, right? So you can definitely put this limit outside of the log, which means that you can say this is uh, limit x tends to 0, sorry, x tends to a log of 1 plus fx over gx. You take this gx now outside because it's log limit x tends to a. This will be gx, and now this is log of 1 plus. Okay. Yeah. Now this is interesting. See, this gx is going to infinity, that is okay. Fx is going to 0. So what you can do, you want to solve this particular limit, right? So what you can do, you want to solve this particular limit. So basically what I just did, I just took the log and I'm finally here. Now, if you want to solve this, what you can do, you can say that since fx is going to at x equal to a, fx is going to 0. I mean, that's what we have said, right? Fx is going to 0. So basically, since this is going to 0, you can multiply and divide by fx both sides. And this quantity will be 1. See, limit you can take, don't worry about this limit. Limit you can take with this, limit you can take with this limit separately. You can understand that these two limits are separate. Okay, don't worry about taking the limit separate and all. So basically, you can say this quantity is 1, this quantity is 1. So basically, finally, it is coming out to be limit x tends to a gx into 1 into fx, right? Which means it is fx into gx. So basically fx into gx, which is log L. Okay, log L. And now, what is this? Okay, here the log base is e. What is this L? Because we are interested in L. So what will the L finally? L is e power limit x tends to a fx into gx, something like this, or gx into fx, whatever you want to write. Okay. So see, we started with this. We wanted to solve this. I mean, we assume that this particular limit is L. Right? We wanted to solve this and we assumed that this is L. Now, we did some calculation and we arrived of the simplified form of this L. Why it is simplified, you will get to understand. So basically, either you write like this or you write L like this. Is there any difference? See, either you write L like this was given to me, or you write L like this. Is there any difference? I don't think, right? Because this is just another way of writing this L. Let me know if you think there is any difference. Okay. Since there is no difference between these two L, so I will just say that if the function is given to you, which is something like this, okay, which is basically something like this. Just a second. So if a function is given to you, which is something like this, then you can rewrite this function. I mean, you can rewrite this as something like this. Okay, where L equal to e power, I mean, you can take this here, and you can subtract one from this. So which means what I'm saying, that if let's suppose some limit is given to you, and someone says, can you rewrite it? Then you can rewrite it. How? You are going to say that if here, if this is going to, okay, this particular quantity is going to 1, this particular quantity is going to infinity, then you can rewrite it like this. How? You will say it is same as saying limit x tends to a, you are just rewriting it, e power gx you take here into this function minus 1, which is fx. It is just a rewritten form. Okay, so I hope you guys understood. So basically what we need to do, we need to take this outside, and then we need to subtract 1 from here. Similarly, if I just ask you, I'm not going to derive it. If I just ask you, okay, maybe I can go to the next page. First of all, can you tell me why I'm saying this must be going to 1? Because I have used something from here, right? Because see, I have used this. I have used this particular thing where I'm saying that this fx is going to 0, right? This fx is going to 0. Then only I was able to say this is 1, right? So I'm using this to be 1. I mean, I'm using this particular fx is going to 0, that kind of thing, right? Okay. Anyway, like, I mean, I'm using that this function, if you are having something like this, then this particular function minus 1 is going to 0. Or I hope you understood that if it is written like this, then this fx is going to 0. Okay. That's what we have assumed. Then only I was able to write it. Okay. Anyway, let me just ask you one thing. Suppose I say, can I rewrite it something like this? Here fx is going to, I mean, at x equal to a, okay, at x tends to a, it is going to, let's suppose 1, and gx is going to infinity. Can I write it something like this? It is just a rewritten form. Can I write it something like this? Let me know. Okay, so we can write something like this, right? So basically, if this is going to 1 and this is going to infinity, then what we are going to do, e power that thing into this minus 1. Okay, now let me ask you another question. Suppose here sorry, can you write it something like this? If that is the case, then can you write it e power gx into 2 minus fx minus 1, limit x tends to a? Tell me. See, the only thing that you need to check is that this must go to 1. Is this going to 1? Yes, this is going to 1, right? I mean, if you put, if fx is going to 1, then this is also going to 1. Since this is going to 1, okay, this is going to infinity, then you can write it as something like this. So basically, that's the only thing you need to check. Whether this is going to 1 or this is going to infinity, then you can write, okay. I hope that is clear to everyone. Now let's just solve some questions. Okay. Let's solve this question. Here, tell me, is this going to 1? Is this going to 1? Is this going to infinity? If that is the case, then what you do? You just simply rewrite it. I'm just rewriting. I'm not solving it currently. I will be solving it, but currently I'm just rewriting it something like this. This is into cos x minus 1. Okay. Okay. So basically you need to understand one thing is that I mean, if you are having something like this, then you can you can write it like this. Now this is one interesting question. Now we need to solve this. Okay. So basically we have got it. I mean, I have just rewritten it like this. I mean, I have not currently solved it. I have just rewritten it. Why I am rewriting? Maybe by rewriting this will be little easier to solve. Okay. This was my assumption that this is probably little easier to solve. So I want to solve this. Let's suppose this is the initial question that you have. Limit x tends to 0, and then this is e power cos x minus 1 upon x. Okay, suppose you want to solve this. Now, see, don't worry about this taking this limit inside, outside, these things doesn't matter. So basically you take this limit inside, which means this is also limit, you can write it x tends to 0 here also, and you can write here also. It doesn't matter because you can take the limit any number of times. Okay, I mean, why will it matter? Anyway, you want to be requiring it here, can anyone tell me? Because there is no x term. I mean, x term is only here. So if you are going to solve this x with this, then why you need it here? But anyway, if you want, you can write it. Okay, this is cos x minus x. So basically, let's just solve this part. Okay, let's forget about for a moment. Let's forget about everything else. Let's just solve this part. Can you solve this part? Okay, let's just solve this limit separately. This particular limit. I want to solve this particular limit separately. This is 1 minus 1, which is 0 upon 0. Since it is 0 upon 0, you can apply L'Hopital, right? So it will be minus sin x, cos x differentiation is minus sin x upon 1. Limit x tends to 0. And then it is finally 0 only. So this is coming out to be 0. That is why the final answer is, I mean, you can say this limit is coming out to be 0. That is why the final answer is e power 0, which is 1. Okay. Isn't it a very interesting question? Very nice question. Tell me. Are you also getting 1 as answer? So finally the answer is 1, right? This is the answer which is given to me. Finally the answer is 1. Now tell me, suppose this question is given to you. Okay. Suppose this question is given to you. Okay, just a second. I'm not able to copy. Yeah. Suppose this question is given to you, and now you don't know the trick. Okay. Which means trick in the sense, I mean, there is no trick or something. You don't know that you can write it something like this. Suppose that you don't know. Okay, you don't know this. Now my question is that, can you still solve it? Can you still solve it? What is your answer? Answer is yes. How? See, suppose you don't know that you can go from here to here. Then what you will do? Then what you will do? You will be basically saying that, okay, let's apply the long procedure. If you don't know this, then what you will do? The way you have derived, I mean, you will be taking it as L. Let's suppose this is limit x tends to 0. Okay, cos x power 1 upon x. Then take log both side. Okay, log L, which is equal to this limit. We can put the limit at the end. Okay, I mean, it won't matter. So maybe, I mean, that is okay. I will be putting this limit x tends to 0. This is log of this, which is 1 upon x into log of cos x. Right? Now you can solve this. So this is basically log of cos x upon x, limit x tends to 0. Now this is 0.0 form. I think you can apply L'Hopital rule here. So 0.0, how you can apply L'Hopital rule? 1 upon cos x into minus sin x, right? And then this will be 1. So this is limit x tends to 0. Now this will be 0 only. So finally this is coming out to be 0. Okay. So what you got? Finally you got log L to be 0. Okay, not L. Finally you got log L to be 0. That means L is e power 0. That means L is 1. That is also one way to solve it. Suppose you don't know. Okay, if you know, that is okay. If you don't know, then also it is okay. Okay, so earlier also we got the 1. Actually they I think they don't know. They have used the other method, which is taking the log. So actually taking the log seems easy, right? In this case, I mean, taking the log and solving it seems easy. Actually in this case it is easy, but sometimes the using this trick is also very good. Okay, sometimes using this trick. Actually the cases where maybe I will be having some examples. Let me just show you. Just a second. Yeah. So the cases here where it is having 1 plus something, actually then subtracting 1 is actually quite easy. Okay. So if you apply trick now, trick in the sense like you apply this directly simplified form, it is into 3 by n, right? And now n will get cancelled out, it is e power 6. So e power 6 is your answer. Immediately you can answer. So even though you don't know that particular method, then also it will work. Suppose you now you don't know what you will do. Suppose in this question also you don't know that method, then what you will do? I think you will be again. Okay. So suppose in this case also you don't know, then you will be again taking the log. You will be again assuming this is L or some quantity. Right? Now take the log and solve it. Okay. Take the log and solve it. Okay. I hope that is fine to everyone. So basically, if you know, then it is okay. Otherwise, you just apply the long procedure. I think here what they did. Okay, they use some standard limit, which is basically this is saying e power 3. They use some standard limit. Anyway, they solve it using some other way. But yeah, final answer is e power 6. Can you solve this? 1 upon n into n square minus 2 e power, right? So this will be, now you solve this n square minus 2 upon n separately. It will n minus 2 upon n, which is okay, for n tends to infinity. Yeah, that's interesting. Yeah, n square minus 2 upon n is anyway infinity, right? Because this is a higher polynomial. Okay, that is interesting question. Tell me, first of all, can you do this e power or these things? Is it 1 power infinity? Is this of 1 power infinity form? Okay, earlier it was 1 power infinity, right? So is this 1 power infinity form? Since it is not 1 power infinity form, I don't think you can do it. It is infinity upon 0 or some other form, right? This is infinity upon 0. So how you are going to solve this? Just let me know. Just think about it. Maybe you can take log both side, right? If you take the log both side and then you try to solve it. So this is L equal to limit n tends to infinity n square minus 1 power 1 by n. You take log both side, it will be log L equal to 1 by n into log of n square minus 1. I mean here n tends to infinity obviously, right? N is going to infinity. Now this is infinity upon infinity form. You can apply the L'Hopital rule, which will be 1 upon n square minus 1 into 2n divided by 1, right? Now this is limit n tends to infinity. Now which is coming out to be 2n upon n square minus 1 limit n tends to infinity, right? This is the thing, right? 2n upon n square minus 1. Now you take, since it is infinity upon infinity, what you can do, you can again apply the L'Hopital. It will be 2 upon 2n. Now since it is 1 upon infinity, which is 0, so finally this limit is coming out to be 0, right? I mean this particular limit is coming out to be 0, which means log of L is coming out to be 0, which means L will be 1. So the final answer is 1 here. Okay, so how we are solving? We are taking the log and we are solving it. Is this okay to everyone? Yeah, so basically, even though the direct formula is not applicable, that is fine. I mean, you can take the log. So basically, it is the form of, I can say infinity power 0 or something like that, right? I mean, that's what I'm saying. If that is a power question, okay, see, if that is a power question, any of this form, okay, any of this form, whether it is 0 power 0, infinity power 0, 1 power infinity, if that is a power question, then what you do? Take log and solve it. If it is 1 power infinity, then we have directly one method, I can say, okay, and that is also sometimes that is also not very useful. I mean, useful in the sense it will make the question little lengthy. Okay, it will be making the question only less lengthy whenever it is something like this, whenever the form is 1 plus something like this, right? Then I think then only it is proven to be useful. Otherwise, it seems like that this 1 power infinity, the way we have derived, it is not useful. The direct formula might not be useful. Okay, so if it is a power form, then what you need to do? Take log probably. Okay, so basically what I'm saying is that I mean there is no direct method. You need to apply your intuition that how to solve this particular question, right? Okay, so basically the final answer is 1. Okay, I mean they have used some other method, but that is fine. But the final answer is 1. We are also getting 1 as answer. This question is one standard question. Like I don't remember the university name, but it should be, I think, Berkeley University or some other university. I don't remember. But yeah, this is one standard question that we have. I hope you understood. Okay. Now, this is infinity power 0, right? This is also not 1 power infinity. What you need to do? Take log and solve it. Can you do it as an homework? Let me know. Take log and solve. Right? This is, remember, this is not 1 power infinity. Okay, this is not 1 power infinity. You can take the log and solve it. Okay, I mean you can match the answer. The final answer is E. Okay, just try doing it. Yeah, this is 1 power infinity. Now our trick that we derived is quite handy here, because this is 1 plus something and this is 1 power infinity. So let me immediately apply that trick. इतनी मेहनत की है तो क्यों नहीं? E square is the answer, right? E square is the answer. Okay. Now let's solve some of the previous year questions. Okay, now let's try to solve some of the previous year questions. Suppose I want to solve this question, which is saying x into e power x minus 1 plus 2 cos x minus 1 upon x into 1 minus cos x. Suppose you want to solve this. So now we are solving basically some of the previous year question. Let me know before that if everything is fine. Is everything fine till this point? Okay. Okay. So since everything is fine, let's just see. So let's try to solve this question. Now, this question is saying that you want to find out the limit x tends to 0, x into e power x minus 1 plus something and upon x, right? Something like that. So maybe I can take this question on the next slide and let me just see how we can solve this question. So basically for all of the limit questions, what I'm saying is that, I mean, we have seen how to solve, right? What I'm saying, either you apply L'Hopital rule or some either you take the log or maybe some standard limit or something like that, right? Okay. So do you remember there is one standard limit, e power x minus 1 upon x, limit x tends to 0, it is 1. Right? So maybe what we can do, we can take this separate, x into e power x minus 1 upon x into 1 minus cos x plus 2 into cos x minus 1 upon x into 1 minus cos x. Right? Let's just take it as two terms. Now here this e power x minus 1 upon x, this is 1. I mean, you can, if you want, you can just cancel x and x, but this is 1. Now you are having x upon 1 minus cos x. Okay. Plus this is I think minus 2 upon x, right? Minus 2 upon x. Okay. Is this fine to everyone? Okay. Now what you need to do, you can it seems like if you just apply this x tends to 0, this is 0 upon 0 form. So yeah, this is 0 upon 0 minus infinity. So since it is minus infinity or something, what you can do, you can club both of this, right? So it is x square minus 2 upon x into 1 minus cos x. Okay. Or there is some other way? Let me know. Do you think there could be some other way? Sorry, this is x square minus 2 into 1 minus cos x, right? Now let's just solve this. This is x square minus 2 into 1 minus cos x upon x into 1 minus cos x. So here limit x tends to 0. Now how to solve this particular question? Maybe you can take x square as common. Okay, this will be 1 minus 2 into 1 minus cos x upon x square. But okay, I don't think it will be useful, because if x is infinity, then it is generally useful. Okay, so this is basically 0 minus, this is 1, 0 upon 0, right? So basically it is 0 upon 0 form. So maybe you can apply L'Hopital rule, because it is 0 upon 0 form. I think that is the best way. So it is 2x minus this is x square minus 2 plus 2 cos x, right? So it is 2x minus, so cos x differentiation is minus sin x, minus 2 sin x upon this is x minus x cos x. So which is 1 minus, you need to differentiate this, which will be x differentiation is 1 and cos x differentiation is minus sin x. Okay, this is seeming to be longer question, but that is fine. So now if you put again x equal to 0, then I think again it is 0.0 form. Then you can take you can basically again apply the L'Hopital rule. So now if you again apply the L'Hopital rule, it will be 2 minus 2 cos x upon, I think I have the solution on the next page. Okay, so yeah, actually you can do it if you want. I can also do it. So it is 2 minus 2 cos x. Sin x differentiation is cos x, right? Just a second, let me check if there is any mistake. So I think things are going good, right? So it is x square minus 2 plus 2 cos x upon x minus cos x. Okay, so this is 2x. Cos x differentiation minus sin x, or sin x differentiation minus cos x. Yeah, I think that is fine. So now the sin x differentiation is cos x, and then this is basically 1 minus cos x plus x sin x, right? Now if you differentiate this will be again minus cos x differentiation is minus sin x, so it is sin x, and then differentiation of this. Is it going to end soon? That's what I'm thinking. So what do you think? Like, I mean, if you try solving like this, then will you be able to solve this in this way? Let me know. Or there could be some other way. So basically here, I mean, in one of the solution, yeah, I think this is going to end soon. Okay. Yeah, this is going to end soon. So you can just keep on applying it 2-3 times. You need to apply the L'Hopital rule, and then finally it will be the final answer, right? Okay. Okay. Let me know if that is fine. I mean, you can do it as an homework, right? Now let's go to the next question. So here I have x minus sin x upon x plus cos x. So let's just see how to solve this question. So this is infinity upon infinity form, right? How you can solve this question? You can basically just apply the L'Hopital rule here also, right? I mean, this question can also be solved by applying the L'Hopital rule. Okay, so can I move to the I mean, this is one way. So basically this is given to you. Now either you can apply the L'Hopital rule, or maybe I have taken the x common. So you can take the x common. This will be 1 minus sin x upon x upon 1 plus cos x upon x. Limit x tends to infinity. Now can you say that sin x upon x, this quantity is 0 and this quantity is also 0 if x tends to infinity? Because this is a finite quantity upon infinity, right? So that is why this quantity is 0. Similarly, this quantity is also 0. So it is 1 minus 0 upon 1 plus 0. I mean, easily you can say this is 1. Without L'Hopital also you can solve it. See here, this sin x upon, the sin x upon x is basically 0. Why? Because this sin x will be between minus 1 to 1. Whatever you do, this sin x will be between minus 1 to 1, right? And since it is between minus 1 to 1 upon infinity, then it is definitely 0. Okay. Okay. So I hope this is fine. Or you can apply the L'Hopital rule, and then you can get, yeah, there are many ways to solve this. Now let's just solve this and let me know what is the answer you're getting. Okay, what is the answer you are getting? One. Let's just see. Correct answer is B, e power minus 2. So are you getting B? See, this is you can say 1 power infinity, right? So it is e power 2n into minus 1 upon n. So yeah, this is e power minus 2. So that's very easy. I think that was the easy question. So yeah, everyone is getting B. Right. Okay. So basically, I mean, if you know that trick, then you can solve this easily. Otherwise, also that is fine. I mean, in both the ways, it is fine. So it is not 100% necessary that you know the trick. You can always I can say you can always do one thing, which is basically applying the log, and then you can solve it, right? Okay. Cool. Now let's just move to the next question. So this is x power 1 by x, limit x tends to infinity. So this is infinity power 0. Can you apply the trick? No, right? What do you need to do? You need to take the log and solve it. Okay. So here L equal to limit x tends to infinity x power 1 by x. Can you take the log? Log L equal to limit x tends to infinity. This is going to be 1 by x into log x. Now this is infinity upon infinity. Apply the L'Hopital rule. This limit will be, you can easily find out, this is just 0. Okay. So see, I just got this, and this limit is going to be 0. Just a second. Okay, so can you also tell me that intuitively why this is 0? Because if you have seen the algorithm, that log is basically very small quantity, right? Compared to this x. So all of these asymptotic notations formally are basically defined with respect to limit. But we have not seen the formal definitions, but that is fine. I mean, formal definition we have seen, but this limit definition we have not seen. So basically you can say this is 0 because log is very small number compared to this x. Okay, so that means L will be e power 0, which is 1. So that's how you can solve this question. Let me know if you have also got the same answer. Right? Okay. So if there is any confusion, you can definitely let me know. Cool. Now let's move to the next thing. Yeah, that is fine. Your final answer is 1. Okay. Let's solve this question. This is 1 plus x square power e power minus x. Yeah, that's good. Which is limit x tends to infinity. Okay. This is a good question. Is this infinity? This is basically infinity power 0, right? Infinity power 0. Tell me, can you apply the trick? Actually, I don't think you can do it, right? Because this is not 1 power infinity. So take log. Okay. So maybe take log and solve it. Sorry. Yeah, I'm here. So let's just solve this particular question by taking the log. So let's suppose this is L, right? So log L will be limit x tends to infinity. You take this log, or maybe let me write it, e power minus x log of 1 plus x square. Which means finally what you want to solve is this quantity. Finally you want to solve this. Log of 1 plus x square upon e power x. Right? Now, now you can see this is infinity upon infinity. So what you can do? You can apply the L'Hopital, right? I think you can apply the L'Hopital. So this is 1 upon 1 plus x square into 2x upon e power x. Okay. So which is going to be 2x upon e power x into 1 plus x square. So 2x upon e power x into 1 plus x square. You want to solve this where x is going to infinity, right? I think x square you can take common. So it will be 2 upon x. Or there is any other easy way. So x square if you take common, yeah, that is one way. So what is the way that you can think of here just to solve this question? Let me know. What is the way that that you are thinking? Just give it a try. Okay. Should I show you the question again, the original question? No, today I don't think we did it, but that's fine. Okay, this is log of 1 plus x square upon e power x. Actually, directly, I mean, we can solve using L'Hopital and all. I mean, that is okay. But directly, by looking at this, directly, can you say this is going to be 0? Directly, can you say? Can anyone tell me the intuition why directly this is going to be 0? See, this e power x is actually extremely large, right? I mean, don't get afraid with this 1 plus x square or something. I mean, this in this log, this constant, I mean, inside this, it won't matter much. Basically, it is just log x. I mean, if I just ask you, what is the, see, this x is tending to infinity, which means you are talking asymptotic sense, right? What is this? Even log x upon x is, when x is tending to infinity, even log x upon x is 0. Then e power x is too much, right? So it will be definitely be 0. So it is 0. Similarly, if it is x square, will this matter? No, it is just 2. You can take outside, it won't matter, right? So this is also 0. So basically this is also 0. If it is 1 plus x square, then this 1 is also very small term. I mean, 1 is also very negligible. So this is also like 0. I mean, asymptotically, if you have seen that data structures lectures, then you know that log x and e power x, which one is larger, right? So intuitively you can say that this quantity is 0, or you can solve using the L'Hopital. I mean, it is up to you. Okay. So you can confirm with the L'Hopital later, but this quantity is 0. So finally I got that log L is 0, then L will be e power 0, which is 1. So basically 1 is the answer here. How we solved it? We took log and then we immediately saw this, we identified that okay, this is going to be 0. I mean, you can reconfirm it, that's not an issue. Okay, see, in case of log, this constant does not matter much. I mean, if it is, let's suppose if it is n power 1 plus n or something, then obviously this constant 1 matter. Why? Because this is n into n power n. I mean, this is not just 1. See, what I'm saying, if you are having n power 1 plus n, then will this constant matter or not? Yes, definitely, because this is n into n power n, right? This is n into n power n. So this is not 1. This is basically n. This is n. That is why this constant matter. But in case of log and intuitively, I'm just telling you. In case of log and all, these constants won't matter much. Okay. This constant, because this is just, n. With respect to n, this 1 is nothing. But with respect to n, you can say this 1 is nothing, but it is not 1. It is not 1. That's what I'm saying. Okay. Cool. So 1 is the correct answer here. Let's just see how people on the GATEOverflow has solved it. So people on the GATEOverflow has taken this, then they have applied the, I think, oh nice. Someone has applied the same logic that e power this grows asymptotically slower than denominator x such approach to infinity. Nice. So here also someone has applied the same logic, okay, which is quite good. Okay. So you can solve this. Now let's just see if you can solve this. What is the answer here? I think this question is very much straightforward. You can directly tell me the answer. See, this is something which is going to 0. This is something which is going to 0. If both are the same quantity, if it is this is same as sin x upon x, right? Where x tends to 0. So it need not to be just x. It is x means x is one representative. Okay, which means something which goes to 0, same exact same thing here which goes to 0. Then this is 1. This is 1, right? So this is just 1. Okay. Let's solve this. This is 1 minus 2 plus 1 upon 1 minus 3 plus 2. So basically this is, I think, 0.0, right? Since it is 0.0, you can just apply the L'Hopital. Yeah, I think you can apply the L'Hopital, or there is some other way to solve it. Maybe let's just once apply the L'Hopital so such that this constants will go away. Otherwise, I'm not able to factor it out. So maybe let's just apply the L'Hopital once at least. Okay. Yeah. Now let's just see what is happening. If x tends to 1, then this is 3 minus 6. This is 7 plus 10. So this is 17 minus 3. 17 upon 3 minus 6. 7x power 6 minus 10 x power 4 upon 3x square minus 6x, right? Okay. If x is 1, yeah, this is 17 upon 3 minus 6, which is minus 3. Oh, there is some mistake or something. 7x power 6. Sorry, this is minus. This is minus. Yeah. So since this is minus, this is 7 minus 10. 7 minus 10 is minus 3. And this is also minus 3. So final answer is 1, right? So that's why C is the correct answer here. Okay. Okay. So I hope you understood. Now you can solve this question. This is x power 14. I think you can solve this easily, right? By taking the L'Hopital or whatever you want to do. So you can use the L'Hopital and then you can solve it. What about this? So this is 2x plus 22 minus 4 upon x plus 3. So if x is going to minus 3, limit x is going to minus 3, then this will be 0. This will be, this is 0. And then this is minus 6. 22 minus 6 is what? 16. So this is again 0. So you can use the L'Hopital rule here, right? Or there is some other way. I think L'Hopital rule you can apply. So using the L'Hopital, you can solve this question. Okay. So this is 0.0, and using the L'Hopital, you can definitely solve this question. Now, like we are done with limit, and also we are done with the continuity. So basically, I will define the definition of continuity, and then you will see it is same as limit. Okay. So basically in the limit we have seen that if we are coming from the left and then we are coming from the right. Okay. If we are coming from the left and we are coming from the right, if both the function's value matches, okay, both the function value matches, then the limit exists. So which means I will say that limit x tends to a fx, this quantity is same as limit x tends to a minus, okay, or maybe in another way, let me write something like this: h tends to 0, f of x minus h equal to limit x tends to 0, f of x plus h. So basically, I mean, if I'm saying the limit exists, then this left hand limit and right hand limit both are same. And then we say function is also continuous. So basically in the continuity, what we say, okay, let me go to the next slide. So in the continuity, what we say that function is also continuous means that at this particular value, at this particular point x equal to a, the function value is also same as whatever the limit value, which means here so I will say that in the limit this is equal to this, in the limit this is equal to the left hand and right hand limit, both are same. This is equal to this. This is enough for the limit. For the limit, this definition is enough. But for the continuity, you need to have this is same as fx, or maybe let's suppose I'm saying at a, then this is enough for limit. But for the continuity, you have this additional, which means if both the points, left point and right point are same, and function is also taking the same value, then you say that it is continuous at the point A. Okay. For example, that if I say that there is some function, let's suppose this is the function, then can I say this function is continuous at point A? The answer is yes. Why? Because you come from the left, you come from the right, and at this function value, all of them are same. Right? The left, right, and this function value, all of them are same. That is why this function is continuous at A. Is this continuous at, let's suppose at any other point? Let's suppose this is the point where we have, let's suppose this is B. Okay. Where the function value at B is basically something like this. Okay. So here at A, function is contiguous. At B, only limit exists, but function is not contiguous, right? Okay. At B, only limit exists. Let me know if that is okay to everyone. Cool. So basically at B, only limit exists. Now, why I'm saying this? Because at B, left hand side, right hand side, both are same, but that's not same as the function value. Okay. So that's what the definition of continuity is. That I think that's what you already know. So a function is continuous, as we have seen on the YouTube lectures also, that if that is same as A, so this is very important, right? Which means the limit and the function value is same. Limit means what? Limit itself means left hand limit is equal to right hand limit. That is same as the value of the function at point A. Okay. So suppose this is the fx that you have, and we want to check whether it is continuous for x equal to 0. Now what you need to do? You need to check if it is, you need to check the value at x equal to 0, which is basically this particular value. You can check where it is 2 upon 1, okay, which is 1. And you need to check after 0, before 0. Okay. So basically, if you want to check whether this function, let me copy this. Suppose you want to check whether this function is contiguous at x equal to 0. Now just check f of 0. What is f of 0? This is, since this is defined at 0 here, so this is 2 into 0 plus 1 upon 0 minus 1, which is 1 upon minus 1, which is minus 1, right? So f of 0 is minus 1. Now we want to check, we want to check continuity, which means we also want to check at 0 minus, just before 0, just after 0, are these values same, which means limit exists, and is this also same as f of 0. Okay. So tell me what is 0 minus. So this is f of 0. I hope that is fine. Now let's just find out 0 minus, right? Okay. So 0 minus means, if you want to find out the 0 minus, it means you are saying, so this is f of 0. Okay. So f of 0 minus, it means you are talking about this particular function, which is 1 plus 0 square root, right, minus 1 minus 0 upon 0. I mean, okay. So basically here, since it is not exact 0, you need to do it little carefully because the limit does not, limit does not very intuitive. So what you need to do, you need to say that this is same as saying 0 minus h, where limit h tends to 0, right? So which means here, instead of like you use this function and instead of x put 0 minus h. So this is 1 plus k into 0 minus h square root minus 1 minus k into 0 plus h square root upon 0 minus h. So this is the function value at just before 0, okay. So this is 1 minus kh. Now you can solve it. 1 minus kh square root minus 1 minus, this is 1 plus kh square. So yeah, this is 1 minus kh and this is also 1 minus kh. Is this? This is 0 minus h minus, 1 minus kh, 0 plus h. This is also 1 minus kh, minus h. And since this is going to cancel out, so I think this is going to be 0. And what is the 0 plus? This is minus 1, okay. At 0, let me check if there is any calculation mistake. So at 0, you are getting minus 2. They are saying find k if fx is continuous at x equal to 0. This is 0 minus h, sorry about it. So this is 0 minus h, okay. I mean, I made it plus h, but yeah, this is 0 minus h. So basically you need to find the limit at x equal to 0, which is going to be, maybe I can do one thing. I can do this question from the scratch, okay, on the new page. So this is the question that we have. And we want to find, the question is that we want to find the value of k if function is contiguous at x equal to 0. If so, how you are going to do it? What is f of 0? F of 0, I think very easy. This is 1 upon minus 1, which is going to be minus 1. I hope that is clear to everyone. Okay, so I think here the f of 0 that is minus 2. I think this is by mistake, okay. So f of 0 is coming out to be minus 1. I don't know why they have written minus 2. I mean, why I have written minus 2 earlier. This is 1 upon minus 1. So based on this function, it is coming out to minus 1. Anyway, let's not worry about it. So basically f of 0 is minus 1. Is this clear to everyone? You put directly 0 and then you will be getting 1 upon minus 1. Now let's just find out what is f of 0 minus, okay, and what is f of 0 plus. See, these three quantities must be same for the function to be contiguous, okay. Now f of 0 is coming out to be minus 1. Can anyone tell me what is f of 0 plus? For 0 plus also you are going to apply the same thing, right, which is almost 0. Since you are going to apply the same thing, then you can put, I mean, this is 2x plus 1 upon x minus 1, right, and x is defined here in the range of this, okay, cool. Now you want to find out f of 0, and then what is this 0? That will be 2 into 0 plus 1 upon 0 minus 1, which is coming out to be minus 1. Now what is f of 0 plus? For this also you are going to use the same function. And now also, I mean, you can do the whole calculation, which is something like this, okay. I mean, f of 0 plus is nothing but saying this thing, limit x tends to 0, sorry, h tends to 0, f of 0 plus h, Okay, 0 plus means just after 0, which means 0 plus h, which is basically you can put 0 plus h and all, so it will be just h. So it is 2h plus 1 upon h minus 1 limit h tends to 0. Now it is simply minus 1. Okay, or you can directly apply x equal to 0 plus m in here, and you can intuitively say that it is also minus 1. So basically just to check whether the function is contiguous or not, these three quantities must be same, but these two quantities were extremely easy to find out, which is minus 1, minus 1. Now let's just find out at 0 minus what's going to happen. Okay, so this is the function that we have, and now we are going to find out at just before 0 what is the status, right? Just let me remove all of this. Okay. Yeah, just before 0, let's just see what is the status, which means f of 0 minus, which means I'm talking about limit h tends to 0 f of 0 minus h, which is basically Sam is saying you put like here you put 0 minus h, which means minus h, right? You put just minus h. So basically this is 1 plus k into minus h minus 1 minus k into minus h upon minus h, right? So this is square root of 1 minus kh minus square root of 1 plus kh upon minus h. Can you solve this? I think you can rationalize and you can solve it, right? So just multiply by square root of 1 minus kh plus square root of 1 plus kh upon the same thing, which is square root of 1 minus kh plus square root of 1 plus kh. Now it will be 1 minus kh minus of 1 plus kh, okay, divide by this thing, so which is minus h into this whole thing, right? Square root of 1 minus kh plus, okay. So now from here you can see this is 1 and 1 will get cancelled out. This is minus kh, so it is minus 2 kh, right? Minus 2 kh, and which means minus h will get cancelled out, which means it is k upon something like this. And if you put h tends to 0, this is 1 plus 1, which is just 2, right? So this is going to be k upon 2. Now you got f of 0 minus to be k upon 2, f of 0, which is same as f of 0 plus, you got as minus 1. Now since all of this has to be same for continuity, all of this has to be same, so f of 0 minus equal to f of 0 equal to f of 0 plus, which means kh coming out to be minus 2. Okay, so that's how you can solve this particular question. So basically for the continuity, all of this has to be same. That's the only point I want to make here. Okay, I hope that is clear. So this was the question which was given to us, right? We want to find out the value of k such that this function is continuous at x equal to 0. So at 0 minus 0 plus, you need to find out all of this quantity, and then you can equate all of them, then you can find out the value of k. Okay, cool. Now if f and g are continuous at x equal to a, then this plus minus these things won't matter. These are also continuous, which means this is also continuous, multiplication is also continuous, division is also continuous, as long as this is obviously not 0. Okay, cool. So we have solved all of these questions. We have solved all of these questions on the YouTube videos. You can just go over these questions, right? So basically here I'm asking whether it is continuous at x equal to 3 or not. It is easy question. You can just go over that. Okay. Now we will be starting differentiability. But before that, let me know if everything is fine. So we can start the differentiability in next session. So basically continuity and limit are not different. Okay. Continuity and limit, these concepts are almost same. For the continuity, you need to just have extra term, which is f of a,
Okay, just f of a, which finding f of a is always very easy, which is a minus, which is a plus. Okay, here in the limit you say this is a minus and a plus. What do I mean by a minus? It is same as saying limit h tends to 0 f of a minus h. What do I mean by a plus? It is same as saying limit h tends to 0 f of a plus h. I mean here 0 means it is basically 0 plus. I mean if you are a little bit confused, 0 plus means it is actually the positive number. Okay, h is a positive number, then only this a minus h will be little lesser than a, right? I mean h is a positive number. H is very small, which is going to 0, but it is a positive also. Okay, it is a positive number also. Cool. So that's how you can understand this limit and continuity. So we have solved all the PYQs as far as I understand, almost all. Okay, so we have solved all PYQs here for limit and continuity. Now we will be starting differentiability in the next session. Okay, so I hope you have understood all of this concept. These are just easy concepts. Don't worry about this limit and continuity. You can just find out the limit using some trick. So basically, I mean, what do I mean by that? So there will be different forms. Okay, there will be these different forms, and then you know now that how to solve these forms, right? That's all about the limit. Okay, so thank you everyone. We will be meeting in the next session. Thank you so much. Take care. Bye bye. If there is any doubt, you can just comment it out. If you have understood all the things, just let me know so that like we can bring more session like this. Okay, just let us know that you have understood all the things. Just comment it out that okay, in the comment just write only one word. You don't need to write all the story. Just comment just understood. Okay, understood everything. Just comment it out this word. I mean these two words, which is fine. Just comment it out so that this YouTube recommend this particular video to